Alright, so I think we're good to go now, guys. Does this laser pointer not work on the light theme? Ah, a quick side note. This is how all the presentations look at the RIT-Sec Physical Security Interest Group, so I figured I would make them thematically similar. So we're not going to be able to use the laser pointer apparently. Like, look at that. You can't see that, can you?
No.
No, you can't. All right, but I do have a clicker that doesn't work. Sick.
Click on the PowerPoint.
Just click the button on the laptop. You lazy
Click the button. Go like this.
lazy piece of shit. Come on.
Now try it. Oh, dude. All right. So this is my intro slide. I don't know how many of you guys know me. I'm like around. My name's Loudon Mailing, third year physical security interest group guy. I also am a part of the RIT Beekeeping Club. Little known fact, fun time. If any of you guys want to like join that, you can like message me. They have a Discord. Shit, I hit the thing. All right, I'm gonna not do that again. And follow me at Loudon's Car on Instagram if you haven't already. That's kind of a requirement. Those are my cars there. Big fan. And I don't know if you can read this. You might want to, but you could do that on stream or something. Anyway, so today we are going to be taking a look at some sketchy stuff, potentially, if you were to use it in the wrong way. So, I don't know, I was not here directly for the beginning, but there's usually a preface that the things described in this club should not be used for unethical purposes. You wouldn't want any issues with Johnny Law or anything of that nature. So yeah, here's my overview slide, basically what I just said. But the idea here is usually I pick a topic like something lock related. Here I'm just going to be going over like all the entry methods. Because usually lock picking, it doesn't actually get touched that often in a physical pen test or something like that. So I just figured, and this was what John B had wanted anyway. He was like, dude, cut all that lock stuff, bro. People aren't going to be awake for that. So yeah, I just try to put together an interesting combination of things that you may or may not have already seen. Speaking of things you've already seen, who's seen the videos of the motion detectors being set off by the canned air? I figured I'd just put this in here as a bit of a side note. It's kind of well known at this point, but for those of you not in the know, some facilities will install these egress sensors to trigger like electronic locks from the inside, so that you don't have to like click anything when you're leaving the building. It just senses that you're there. And some of them have built-in like heat detection and stuff. They're kind of advanced. So what people will do is get this electronic computer duster, right? And you flip it upside down. Who's ever done that before? You just, it sprays all this weird cold air. You can like freeze stuff with it if you're really trying. But you just spray it through the top of the door and it'll trigger the sensor here and then you can get in. That's a good one. Fun times, really. But I would imagine you've all seen that one. This one may be a lesser known one. If you're presented with a locked door, right? One thing that you can look for is exposed hinge pins. You could just take the hinge pins off, walk the door off its frame, and boom, you're in. It doesn't matter how advanced their lock was. You can just do that. Like, there are countermeasures though. There's what's called a security hinge, which is more advanced. It basically has just like a peg that comes out here. Oh wow, that's a weird texture. It's like a bunch of little LEDs. It's got a little peg that comes off the hinge and goes in the other side of the hinge. So if you take the hinge pin off with the door being shut, you can't just steal the door. But those aren't like super common. If you keep an eye out for them, I don't know. I don't think there are really any around here. Not that I've been keeping an eye out for it. I mean, this attack is so basic. You can find it on WikiHow. Like, that dude's doing it. Right. Okay. So this is a good one. I have like 3 slides about this one. who's ever seen a latch on a door? I would imagine most of you have. So there are two portions here. You have the actual latch. Oh man, the laser pointer would be great right now. I don't know how well you can see that, but I could just describe it with words. You have this little like half cylinder thing here sticking out right next to the latch. That's very important. That's known as the deadlock plunger. And that prevents a couple of attacks that one could do if it were installed, say, improperly. Um, so what happens is when you go to shut the door, right? The this whole mechanism is compressed by the strike plate, and then it kind of pops back in once, because it's a spring-loaded mechanism once the door is shut to kind of keep anyone from opening it. You know, like how doors are supposed to work. Um, so the deadlock plunger is installed on these to make sure that it won't be compressible again until you retract it with the actual handle for the door. That's the idea. So that, like I said, when you go to close the door, it's springy and it'll bounce back. But once that pin is depressed, it's not going to move anywhere. And that's how it's supposed to be installed with the proper hardware. The proper hardware will make it so that this part only sticks through and the pin is depressed. However, you may have seen some of these before. These are, I believe, the technical term that I Googled to get this image was something like electronic door latches or electronic strike plate. These are used when you have a swipe system on the door. And generally what'll happen when you have a large contracting firm build your building, they just keep a stock of whichever one has the largest opening and will fit all doors. So you could imagine, seeing as you need a very specifically sized hole for this deadlock plunger to be depressed, if you were to use something, say, very large, that it may not be depressed. And this can lead to all sorts of interesting attacks. So basically, you've got like a couple of options. If you're faced with the if you know how a door frame, it'll stick out in front of part of the door, and you won't have direct access to where the door actually meets the frame. If you have direct access to where the door meets the frame, you can use something like this. You may have seen one of these before. It's just a variety of metal implements for getting in there and kind of pressing up against the angled side of the the latch, okay, and opening the door. Now, these are not the end all be all. I know there's like these wire ones that are kind of shaped like a hook, and if it's got a latch guard on there, you can kind of stick a long wire behind it and just like pull it forward. I've seen that. But say you don't have access to directly to the side that has this on it, and you have to work around the door frame. That's where these things come in. These are some plastic shims. I believe we ordered some for the RITSEC Physical Security Interest Group Mondays from 11 to 12 in Golisano 1730. Oh, God. They are just kind of like flexible plastic that you can stick around the curvature of the door frame and get at that latch and depress it, and then you'll be able to open the door. There's actually a common substitute that I found recently, and that would be a garbage from the trash. You could just cut out a piece of plastic from, like, I think a Wegmans cookie tin works pretty well. That was my experience. Just like pretty low effort stuff here. Like, just it's because they didn't install the thing properly, right? This could have all been avoided. You just got to keep an eye out for this stuff. I don't know if you've been looking around for it, but there are some egregious examples around recent constructions at RIT. Um, so here's another one. This is a fire code dictates that these be on a lot of doors. I would imagine you've seen one before. They're called panic bars. I also heard them referred to as crash bars. The idea here being that if there's a fire and you need to get out really fast, you don't have the time to be fumbling with a handle. So you just like kind of smash into the door and it opens. If these are installed incorrectly, they can be a real problem for security. So this was the best image I could find on Google Images, and I think you'll be able to see the laser pointer like semi decently on it, I imagine. So you see the separation here between the doors. Generally, you want that covered up with some form of metal, or else people like that on the left over there will be able to stick various pieces of molded wire and steel bars through there and kind of smack on them. Now, often when these come installed, there's like a secondary mechanism down there, usually below them, like a thumb turn kind of deadlock dealio that would kind of prevent this attack, even if there was a sufficient gap. Like generally, if you can see light between the doors, that's a bad sign, because you could probably stick something through there. So yeah, if you want, if you got that, you might want to use the deadbolt, but it's a lot of fire code stuff, so you just kind of have to have those on buildings. Speaking of those deadlock, those thumb turns, right? They're not the be-all, end-all solution. There's actually also tools for defeating those. I think these are like $20 or $30 online. It's just this little bent wire that goes through a sheath, and then you can spin the lower part of the handle, and if you get it on a thumb turn, you'll be able to open it. So you really want to make sure that those areas between the doors are sufficiently not letting sunlight in. As far as deadbolts go, I know that there was these have different latching mechanisms. So remember when I was demonstrating earlier that you could just kind of stick something through the door and open it. That won't work if there's a deadbolt because it just kind of sticks out. There's not actually any spring mechanism that's kind of pushing it in and out. Now, this is another one, a bit of an under the door attack here. Now, I don't know if you've been paying attention, but have you ever seen a door knob, like an actual knob here at RIT or any like corporate area? My guess is gonna be no. They've all been kind of replaced with these. Oh man, the thing doesn't show up. These lever style hand. These lever style knobs, right? And so that leaves an interesting vulnerability if it's kind of allowed to be unlocked from the inside like that. If there's no deadbolt present or anything of that nature, you can slip this weird like old-timey criminal tool into the door that it's just a big bent piece of wire that brings a piece of rope or string up around the handle for the door. And once you do that, it's kind of tough because like you can't really see what you're doing unless it's like a glass door or there's some glass next to it. But once you get it, you could just kind of pull down on it like that, and it can open the door. So notice I haven't spoken anything about locks like this whole time.
Whoa.
Exactly. There's so much more to physical security, and I do outline this stuff at the RITSec Physical Security Interest Group Mondays from 11 to 12. There's like 2 weeks on it, you know, no big deal. Okay, so badge cloning. I bit the bullet and finally researched this stuff. I was hoping Jake would give a presentation about it, but I mean, he didn't, so I did like 30 minutes of watching stuff on YouTube. So there's a couple of different protocols for RFID. That's this one here. Those are the ones where you just kind of hold the card in front of the reader, and then it opens the door. And to my understanding, the way that works is you've got a little coil inside of the card. You've got some magnetic induction going on from the reader. It sends a little bit of power, kind of like the same way, you know how like a cell phone charges wirelessly? Same deal, just a magnetic coil or coil moving through a magnetic field inducing current. And then there's a little chip that'll send out a radio frequency to the reader, and the reader will read that. And there's various protocols for it. The oldest of which, it just sends like a magic number. I believe there are more complicated ones now. However, there are still places that use like legacy ones that will accept both. And so here we have a like $20 China Mart badge cloner for like the oldest standard of these. So all you got to do, get your valid card that you've stolen in a ethical way that would not breach the RITSEC Physical Security Interest Group ethics policy, right? And you hold this bad boy up to it, click read, get all the data off there, and then you get a writable one. Not all of them are writable, by the way. And you write the magic number onto there, and it'll work on the reader. That's like the most basic level understanding of RFID. And then you also have your standard like scan cards there with the mag stripes. That is it's a layer of iron 2 oxide. Iron 3 oxide is the one you make thermite with, the black kind, and it's allowed to hold a magnetic charge, right? And it comes out kind of like binary there. I believe what someone did to make this image is kind of stuck some sort of iron powder on top of an existing card or something to that degree that allowed it to kind of show where all the magnetic forces were coming off of the card. But basically what happens is you just swipe it and it kind of reads it like binary. It's like a QR code, or not a QR code, but like a barcode, except it's reading it a little differently, but kind of a similar way of storing data, if you catch my drift. But that's those. I will go into this in more detail, I promise. But you have to come to the RITSEC Physical Security Interest Group. It'll be like a whole week, dude. I'm telling you, it'll be great. And then another thing, getting closer to the lock realm now. We have compromised keys. So I don't know how familiar you are with the issue of people posting pictures of their badges or keys online, but like as we know that badges are bad because you could like copy them and then make a printout copy and socially engineer people to make them think you work there. However, keys, if someone posts a good enough picture of their key, you could actually decode the bidding of the key from the photo and make your own copy. This is a good example here. The TSA just like posted a picture of their keys online at one point. So like they're all super compromised. You could go on like Thingiverse and print one of these things out like with PLA plastic from a 3D printer. Like it might break, but like you could probably still open some locks. The TSA locks are real crappy anyway. Like once I get into lock picking, which I will outline in this presentation, we will go over that. But yeah, so this is like a kind of a low-tech solution. You just kind of figure out what the different heights are here. There's different charts that explain the amount of thousandths of an inch difference between one bidding number and the next, and you could just bring that number to a locksmith or something, and they'll cut you a key. Just don't tell them why. And then you can open said lock that was had a key posted of it online. There was actually a challenge at B-Sides Rochester, like the most recent time that it was in person, I think. Or maybe that was freshman year. I don't know. Anyway, the guy from Tool had a bunch of like Kwikset keys on his belt loop, and he wanted people to come up next to him and take pictures of them, and then go with like Photoshop or something, and actually like with a template kind of decode the bidding of the key, and then from there he wanted you to kind of shave it down yourself. Like he had a gauge. They make different gauges for like the different biddings of the key. And I don't know if that's super clear that I'm saying that now without kind of explaining the different interworkings of a pin tumbler. But comes later. Come to the RITSEC Physical Security Interest Group Mondays from 11 to 12 in Golisano, 1730. If any of this is unclear, or like even if it is clear, you could come still. Like, I mean, we're there most of the time. I mean, Thomas Borelli just rescheduled all my homeworks to be due on Monday, so like maybe I might cancel it, but I'll let you know if I do. But yeah, compromised keys. Picture on the left there. Fire keys also get compromised. You got like, I think it was a New York fire code. They actually just published like the bidding of the key, like in the law that specified that they needed them. That's a elevator one. I'd imagine you've seen something similar to that in the past. But yeah, compromise keys. I believe I have another slide in here. Yes, the ever-present dumpster diving. This gets mentioned sometimes in physical security talks. It's more like a pen testing kind of thing. But if you're gonna be like, digging up info on a company, there's a lot of stuff that like doesn't make it to the shred bin, and you could find it in the garbage. I just figured I'd mention this a little bit. Because it is very much a thing. Justin Pelletier could tell you more, honestly. He's a big proponent of digging in the trash. Okay, getting closer to lockpicking stuff. This we have key boxes. You've maybe seen some of these before, big with realtors and stuff. I think there are some of them around RIT, like this form factor. There's another one kind of more similar to this one that has like a latch on the top that allows you to connect it to doorknobs and stuff. But yeah, so you got these, you got these. The idea being that you have a facility that someone needs access to, but you can't like give them a key because they'll run off with it maybe, or I'm not exactly sure what the use case is. Just like you want to have the key on premise, but you want easier access for certain people. So you put the key inside of one of these bad boys, right? And that solves the problem. All they need is a 4-digit code and they can get the key to your facility, right? So you can see how this would maybe introduce some security problems. These in particular are awful. If you get like a really thin piece of metal and you stick it in this, oh dude, this will work. Yeah, you see the laser pointer? This little gap right here between the dials, you can just decode it really simply. You just kind of spin the dial and stick the small piece of metal in there. There's one recessed portion on the I believe it's the left side of the dials, but I have a whole week on this stuff, so I mean, RITSEC Physical Security Interest Group, like, I cannot reiterate this enough. But yeah, so you can get into those very simply. I mean, even if you just like show up at night and you just like try all what is it, 10 to the 4th combinations, you could do that. I mean, this one here, even worse. That's got a tubular lock on it. I don't know if you're familiar with tubular locks yet, but you will be by the end of this presentation, to an extent. I mean, I can't go over everything, but tubular locks suck, basically. Like, 99% of them come from, like, very similar manufacturers in China and can be exploited like very simply with self-impressioning tools. So if you put your nice key for like a good lock in one of these, like right outside your facility, like, I mean, you've kind of really undermined yourself there. Like, somebody could just walk up with some little pieces of metal or self-impressioning tool and have your key, and like, it doesn't take a rocket scientist to use a key. Anyway, so that was enough not talking about locks. I mean, frankly, I was getting sick not talking about locks in a physical security presentation. So here we go. I made this like in 5 minutes the other night. I know this is kind of a dead meme template, like, but I thought it would be useful to convey some information here on the different types of locks. I have slides for some of the more important ones, but at the top you have disk detainer locks. Those are like pretty high security. They have a bunch of little discs in there that interface with this weird looking key. They can be like found on bike locks pretty commonly. They're pretty good. You got like other, and this is a very high security variant. Probably I can't really read it like an ASA or something. Medico, Multi-Lock. These both have their own weeks at RITSEC. They have some very complex inner work, or at RITSEC Physical Security Interest Group, should I say. They all have their own weeks, as well as this one here, a generic small format interchangeable core. You've no doubt seen one of these before. They're like around on campus everywhere. They have some distinct benefits over normal locks. There's two keys for them, and one will remove the lock. The other will operate it. That's basically how it works. There's a lot of other stuff going on inside there that makes that work, but it has improved security over, say, the next best thing, a normal pin tumbler, which we will be getting into a little bit more on the next slide. But that's a residential deadbolt right there. And then you have weaker pin tumblers below, like a Master Lock number 3, which is pretty much the dog water of all pin tumblers. 4 pins, no security pins. Like, why'd you even bother? You got these here, tubular locks, as I mentioned earlier. Not great. I mean, they're good for filing cabinets and stuff. Like, that's what they're supposed to be on, but not like a box that protects your key for your facility. Wafer locks, very similar deal. Good for filing cabinets. They can also be found on like a lot of cars, like Saturns from the 90s, say, for instance. Like, just totally random example there. And then you have the worst ones. IMO opinion. This is the worst lock. It is the what are those? The warded locks, yeah. So those basically work on this design that's been in use since like man, like the first industrial revolution. No big deal. They just have they were used on railroad switch boxes for a while. They're good for like outdoors use because there's like not a lot of moving parts inside of them. That's like their main advantage. Other than that, you can like stick any old weird piece of metal in there and open them. There's I don't think I'm gonna get into those too much, but I mean, they're pretty bad. You could just get like one tool that opens pretty much all of them. So, conventional pin tumbler. You have many different form factors. You got, and at this point, I'm just stealing slides from stuff that I presented at RITSEC Physical Security Interest Group Mondays from 11 to 12 in Golisano, 1730. You got Master Lock number 3s. You got mortise cylinders on the left there. Those are more common in like corporate applications, and older homes also have them for some reason. But then they kind of cheaped out and went to these. It's a cast design. It's called the rim cylinder. It's held in there with little screws, very commonly found on deadbolts, residential ones. And these are usually, these residential ones here, these three, are more like 5 pins-ish. This one on top there, master lock number 3. Ubiquitous lock, it's like 4 pins. And that one there is a kick cylinder on the bottom left. Can't see that. Yeah, that's a kick cylinder. They are found in knobs, hence the name. Kick is key in knob. It's an acronym. I mentioned this a little bit earlier. SFIC, small format interchangeable core. There's also LFIC, large format interchangeable core. It's the same premise, but there's just like a different mechanism and they aren't compatible. But the idea is you have 2 keys and they can both, one of them will remove this portion here and allow you to install it in any of these different form factors. These are all around campus. You've probably seen them before. And there's another key that will obviously just open lock. Good for like if your key gets compromised, like if the intern posts some pictures online, you know, of the key, like, dude, check this out, new key, just got my new job. Then you can just take all the locks out, rekey them, and then put them back like really fast. It's the best. Okay, so tubular locks, I mentioned these with the boxes that contain the keys. So these are like, yeah, that's right, it does have that tagline up there at the top. These are like pin tumblers, except they kind of stuck all the pins on a different axis. You can easily self-impression them with these tools here. They're like $20 off eBay. The quality isn't so great. Like it's kind of a crapshoot if you buy them. Like the ones that I have are pretty good. The ones that the RITSEC Physical Security Interest Group Mondays from 11 to 12 in Golisano 1730 have are like kind of like B tier. They're kind of mid. Like the manufacturing was like, it was a Friday or something. They forgot to drill some holes. So you got these. They're supposed to be used on like computer locks and filing cabinets. Very easy to self-impression, like 99% of them. There are some like higher security ones, like the Ace 2, which you could find on like ATMs and stuff, maybe vending machines. I know some of you guys with that capstone project that have these with the tubular locks and the self-impressioning. Those are not Ace 2s, so you could just impression them real easy. You can also single pin pick these. I will go into that more in depth, but you just kind of tension it and like poke at all the pin stacks. Dimple locks. You know, I probably should have put like the principles of locks and pin stacks and stuff before telling you all of the different lock types, but I intended to breeze through this kind of. How am I doing on time, by the way?
We got 25 minutes.
Oh, okay. Yeah, so you got dimple locks. These are like basically pin tumblers, except the keyway is sideways and the key looks a little different. It's very similar. They're very common in Europe. Hence this Euro form factor over here. I doubt you've seen a lock like that. It's like upside down for some reason. But also, I've actually seen a lot of screen doors that have that kind of form factor lock on it, or not a lot, but like one at my uncle's house. There's a slightly different tool to pick them, but overall, it's a similar principle. There are some very high security variants of this, which is what the multi-lock is, so watch out for that. But if you really need to know what's going on inside of those, it's like pin and pin. I have a whole week on it, you know. No biggie. Oh wow, what the hell happened to this slide? So this is wafer locks. They're like a very cheap alternative to pin tumblers. The way they do it is they have these stamped out pieces of metal that kind of go around the key and get retracted into the core as you insert it. They pick very similar to a pin tumbler, except with like less feedback because they're kind of chintzy. Sometimes they'll have like shutters on the front to keep the water out. I know John B's froze on his car at one point, so I don't know what was up with that. But there can also be what is it? Single and double sided variants. Like if you can see this key here. Oh nope, wrong button. Okay, yeah. So, single and double-sided variants. If you see this one here, all the little nubs are sticking out of one side. That's because the key is going to raise them all in one direction. However, there's other ones where they stick out of both sides, and when you put the key in, it retracts them from either side inwards. Just like kind of interesting, but I mean they're still like very easy to pick if you're going at it. And then warded locks. As I mentioned before, these are the lowest of the low tier. They are trash. You see this little weird key ring thing over here on the left next to the lock. If you buy one of those online, they're like not very expensive and they can open like all of these kind of locks. So yeah, maybe avoid using these on anything ever. I saw some propane tanks locked up with some of these over by me once. Very unfortunate, I guess. But yeah, they are. The way they work is they have. These are usually laminated, which means that they are a series of pieces of metal that have been punched out of a sheet that are kind of riveted together. Just kind of the typical master lock look. It's a laminated padlock. You can see the different layers of metal in there, right? That have been all riveted together. And some of them will allow the key to move in kind of any way, and some of them are more restrictive and will require these cutouts on the side of the key in order for it to open. So basically, if you want to make a master key for all of these, you shave off all of these that would prevent you from, turning the key, and you can just flip the one lever. There's only one spot in these locks that will allow you to actually open it, and that's usually near the top. Just flick the actuator, and you'll be good. I think that was probably a pretty poor explanation of how these work, but I'm trying to breeze through it. I mean, you can kind of see here the more restrictive plates require that you have a indented portion of the key in order to be turned. But yeah, I do go over these in more detail at the RIT Psych Physical Security Interest Group Mondays from 11 to 12. If you're free. But finally, we're gonna get to some picking techniques and tips and tricks and just very basic stuff. So this is my terminology slide. I'm just gonna go over what all these things are called in case any of you are unaware. I was already throwing out some of the terminology, so like, sorry about it. You got the core, pictured in orange or yellow or gold. You know what I mean. This thing here, that's the thing that will turn. That's what you insert the key into. At the body of the lock, pictured in gray. Got the key pins, all pictured in blue. The driver pins, which sit above the key pins, pictured in red, and springs, which propel them all downwards into the core in their kind of resting state over here. And then you have the shear line, which is the technical term for the line between the core and the body of the lock, where the pins all have to line up in order for it to turn. So basically, if you can imagine here, what happens is you insert the key and it kind of pushes all of these up to their proper heights in order to open the lock. And I was talking a lot about bitting earlier. Bitting is just the length of these key pins, and there's usually about 7 7-ish different lengths of pin. That's about how much they can get away with before they become so close that like one would open another. Um, but yeah, they're like what was it, 20 thousandths of an inch apart. I think a human hair is like what, 3 thousandths. Um, Anyway, so yeah, the bidding. If you could see, if you were to find a picture of a key online, you could totally just figure out which bidding it has and make one or something like that. So now, how can we exploit this design without impressioning or like copying a key online? So tensioning, you may be familiar with this. Um, if you apply some torque to the core, you can bind up the driver pin, the top one in the pin stack. I don't know if I mentioned that term, but the pin stack just refers to all three of these here. It can mean a couple of other things if there's like more stuff in there, but it's just like one column in the lock. So you've got the driver pin being sandwiched between the body of the lock and the core, and that will bind it up and it will not be able to move downwards. So what you can do then is feel around inside of the lock for one of them that doesn't want to move upwards, right? And if you just give it a little bit of a push, get a bit of a click there, like as you see it kind of rotates a little. It won't be that dramatic, but you'll know that you've set it, and then you will be able to move on to one of the other probably 5 pins in the lock. Hold on, do I have one on now? So yeah, they just bind up in a specific order, and I figured I would just kind of breeze over this because most of you are familiar, but I mean, that's it right there. That's the basic principle of all lock picking. And there's like security pins and stuff that can go in there and kind of screw with this motion here, get you caught in a false set or something. But I mean, I'm not gonna get into that here. That could be a whole nother presentation, really. It actually is.
Where would it be?
Oh, just at the RITSEC Physical Security Industry Group Mondays from 11 to 12 in Gonzalo, 1730. How many times would we even meet this semester? For the rest of the semester, like what, 3 more times? I don't know. Your time's running out, guys. We might pick a better time next semester, but no promises. It's usually a pretty crappy time. So now you know how they work. Get into a more randomized attack vector. It still requires tensioning, but say you were more of an unskilled attacker. You were trying to get in quickly on lower tier locks that don't really contain any security pins, and maybe raking is for you. What you want to do is get one of these various squiggly metal tools. Yes, technical terminology. Now you got like the city rake, weird snake rakes. You got the Bogota. This is the best one here, by the way. We have some of these at the RITSEC Physical Security Interest Group. And then these are just like some weird stuff. I don't know why they're included on this image. If I just found this on Google, like I would probably not have included those. But yeah, these are gonna be your main ones here. Like this one particularly. You can. Oh god, there's more tours. What was I saying? So you got this, you got the tension applied, and basically you just kind of shove it in there, and there's some technique to it, and I'm oversimplifying a lot, but you kind of put it in there back and forth, up and down, just trying to move all the pins in a random order, hoping that they will align with the way that they're supposed to be to open, which the key would have done in the normal operation of the lock, right? So raking, low skill attack, just need like 2 tools, very easy. I mean, generally speaking, compared to single pin picking, which is the next one. This is my personal favorite, and generally the thing that I it will take you the furthest. Like all the stuff that I'm outlining here is generally gonna take care of like 90% of situations. This here is if you decide to focus on the hard stuff to learn it because like you think it's fun or something. So single pin picking, right? You're still applying tension. The key pins, the driver pins are being sandwiched. One of them's binding up. You need to find that one. This will allow you to do that in a precise fashion. You just kind of feel around in there with this little hooked piece of metal, and there's different kinds. This is my personal favorite, 25 thousandths Peterson gem. If that won't fit, maybe an 18 thousandths Peterson gem, or if you're feeling like you want to bend it, use a 15 thousandths. But these are one of my personal favorites. You know, just it has a nice shape to it. They're like $8. We have some at the RIT Physical Security Interest Group, by the way. They're club assets. You can use them yourself if you come, but the idea being that you can get precise feedback from individual pins within the lock, and it allows you to pick locks with security pins, which will require said feedback because they are quite complicated. Or here's another low skill attack. You got bump keys. These are fun. So this is essentially a key blank with all of the biddings, as I mentioned biddings before, right? Yeah, I said that. They're all cut to the lowest one, right? So that means that you're left with these little bumps here between them. And what happens in the attack is you will insert this into the lock, right? And you need the correct one because not all the keyways are the same. This one does require a bit more tooling, but you know, if it works, it works. Like it's pretty quick if you can get it down, but it's kind of hard like to learn at first. But once you got it, like it's pretty quick. So you'll put this in there, and you don't put it in all the way. You have it so, for example, this one here, the largest one I have pictured. Actually, I'm not going to explain this one just yet. It has the specific rubber donut, which can be used for agricultural purposes. So you place these in the lock, or one of them, right? And you pull it out by one. So it's got like all of the pins, the keys all the way in there, except no pin is touching the furthest out cut. And so what'll happen is you hit it with a hammer, and all of these little nubs will act like speed bumps and kind of bounce all the pins upwards inside of the lock. Weirdo Newton's cradle type-esque stuff. And then if you're quick enough to turn it whilst all of the pins are like bouncing up in there, then you can open the lock. Like, there's a lot of randomness going on in there. There's still kind of debate as to whether the entire pin stack is being bounced upwards or if it is just the driver pins. However, it works regardless. And that's the general idea, is that you are trying to bounce all of the key pins upwards using these little nubs down there. Now, what is this, you may ask? Now, this is the rapid attack type of the bump key. So what you'll do is, instead of having to pull it back out every time after you hit it, you've got this rubber donut. Yeah, you can, agricultural purposes, that's where they generally come from. But the way that you work this one is you just kind of stick it in there and you hit it like repeatedly, and it bounces itself back out because it has that donut on there. Very convenient, fun times. Oh, how'd that get in there? Anyway, shimming, right? So, another attack vector. This one is against padlocks. We're talking about padlocks now. You got shimming. So if your locking mechanism is a spring-loaded one, this is actually kind of similar in some ways to what I was talking about earlier with the door latch kind of bypasses with the sticking various pieces of garbage from the trash between the doors and opening them. Uh, the idea here is that you are able to remove these locking pawls, as they're called, from the shackle. That's what holds it down and allows you to kind of click it back together without having to do any weird removing of the key or messing around. It's just how most are built. There's some newer or higher security variants that utilize two ball bearings, ball bearing locking mechanisms that will not allow you to do this, but if the gap around the shackle is large enough, you can stick a piece of metal through there. Some people say you can make them out of pop cans, and you can, but they aren't as effective if you do that. You really want to, if you're trying to do this, actually, you probably want to buy some they're not very expensive, and the ones that you buy are going to be a lot thinner and going to work on a lot more locks than ones that you make from a pop can. But hey, I mean, if you're in a pinch, go for it, dude. Now, this is another technique here by the same name that doesn't really operate on the exact same principle. The idea here is this one on the right is core shimming. Now, I should have included a picture, but I'm just going to say this, and some of you will get it and some of you won't. There's if you've ever seen an anti-theft on like a DVD, the little like long plastic ravioli looking thing with the picture of a hand near the top. It's very small. It's like that big. If you take those apart, you can get these little pieces of metal that are very thin. I assume they're doing something with those scanners near the exit of the video store to make sure you aren't stealing anything. But basically, what you'll do is stick this between the core and the body of the lock. And as you remember, I demonstrated earlier, there's a whole line where all the pins are going to have to line up. And generally, the front of the core will be flared so that this isn't possible. Like, you wouldn't be able to stick it in and around. But if it's just a straight cylinder, you can do this. You can just stick that through. And this will be on like some of the bottom of the barrel worst, like Chinese locks you ever seen. This is not super common, but it happens occasionally. And if you have access to a core, like the back of it, you can slip it in around there. But the idea is that you'll stick that in there, and you could just pick it kind of sequentially, as opposed to, like I was saying earlier about how one of them will bind up, and then you'll have to go and find it, and like they could fall back down as you're picking. This works by just sticking a piece of metal in between the core and the body of the lock that will prevent all the pins from falling back down. And it's useful when it works. The idea of this presentation was just to kind of outline a lot of things that could be useful when they work. Don't get excited, it's not over. Actually, is it? Oh, did this thing just stop working? Oh, yo. Zoom, the meeting ended after 40 minutes of idle time.
You were streaming, Jason?
Where's that Jason Howe kid?
Well, that's weird. You were stream sharing, right?
I don't know.
Stream sharing?
The stream fell asleep, bro. It was that boring.
Sorry, you didn't say RTSec Physical Security Interest Group Mondays from 11 to 2, 17:30.
Dude, I guess I didn't say RTSec Physical Security Interest Group Mondays from 11 to 12 and Gauss on 17:30 enough. Alright. Are we live still? Are we on air?
Are you in the Zoom meeting? No.
Plot twist. I didn't have audio on stream at all this time. So Vince, what'd you think?
I'm not a huge fan of that one slide.
Sorry, bro. Way she goes.
It's the way she goes.
The range is busted.
Yeah. Well,
Maybe that was a sign that they wanted you to
Yeah,
stop talking.
yeah, you had to stop mentioning RTC physical security interest
dude,
group.
they got tired. We're
Yeah.
sick and tired.
You only have 4 minutes too.
I only have 4 minutes. Oh, Gotti. I think I'm pretty close to the end of the presentation anyway. Thank you all for your time, by the way.
RTC has ended.
RT second for the rest of the
Nah,
semester.
not gonna work.
Did 3 of the cryptos and 1 of the stegos.
I clicked on a.
But I think he's losing it himself. It's just like he starts talking. He's so like getting tired. So.
Hmm.
Usually don't do
They
it.
were like, there's too much.
Eyes on.
But we started later because of the.
So,
You have any classes?
Yeah, it just asked Josh what he needed, and it was just it was a
Wait, so it requires a pin to get into the meeting? Why do you guys yell leaks then? What the hell?
yeah I suck at web.
The baby web challenge.
I'm about to leak the code to get in. I just heard it, bro.
It's always rad.
John Bauer.
What's going on, man?
Were you here, bro? Everything
Welcome
just fell
to the
apart.
Stream failing.
Oh, cool. We love that. Everything's failing. The CTF's failing.
I have
Loud, you can't talk.
Compared over time.
I can't talk, bro. I've been silenced by the government.
No, you were silenced by
I heard that I was straight spitting, and they cut me off. This man's spitting.
I'm thinking the first one.
Too many facts have been spent.
I feel like.
Quick, shine the laser on Jake.
Yeah, they're not related. That's what I was thinking. I just wanted to make sure. Trying to fix things. He good? Is he good? He looks good, bro. It's fine. Hey, keep going. Keep going. I hear you talking out there. Oh, I saw that at physical security intergroup last week.
Dude, yo!
Trying to rile him up a little bit.
What the? Okay. Clicker broke.
Not
Okay,
the
so there's
Rid of the clicker.
the HDMI is loose on the bottom, so you can't bump the table, y'all.
You just bump the table.
Excuse me.
If you want to see the rest of this
Clicker bad.
presentation, come to the physical security interest.
Leave a cliffhanger.
Get it, Jimmy?
They have to come to club.
Oh yeah, wait.
I just don't know.
Yes.
I've been trying to
Try this.
position the
Oh
club.
fuck, this is a good one.
MAXFUS.co.
Dude, custom mod. We just modded the cyber range.
You
How much
can't-
did
you
this
can't
room
try
cost?
to-
Like
you
$1
can't.
million?
I'd
say several dollars at least.
Whole cyber system.
Huh?
Just some like
Never
random
mind.
family
About-
picture.
Where's this? I'll get yours.
Around 20 quid.
You know, I have that. Thank you, though.
Any closing words?
Are you really gonna cut me off? I got like 3 more slides. Dude, just do the thing you did before, and then I.
Nobody
won't
bumped the
use
fucking table. Right?
Nobody
touched
bumped
the
the fucking table.
True. Nobody touched the table. Can you drag it? Use the shortcut, Jason. Watch this.
Buddy,
Watch
it
this.
doesn't want to work.
Watch this. Use the shortcut.
Whoa, dude.
I'm not on this guy, okay?
Dude, John Bauer just screwed up my slide.
Boom. There you go.
Alright. So, in place of my clicker, I will just do this to Jason Howe, and he'll change the slide.
This works.
So bypassing. I guess we're at a bit of a time crunch now with whatever just happened. So bypassing works by this is another exploit for the locking mechanism of a padlock. The idea is that you stick a long metal thing down the core, and you're able to retract these locking pawls by the way they engage with the end of the core. So you know it's like this long knifey tool, and you might have to pull them both ways. There's certain locks this works on, others that it doesn't, but it's usually the cheaper ones. I believe the term for ones that are not able to stick tools through is shielded. So I know there was a problem with this on American locks for a while, where you would be able to stick this weird kind of flag-shaped tool down the keyway and give it a turn and be able to open them. And those are supposed to be more high security than the average lock. So it was a bad look. They added this wafer at the end, and now you can't do it. Change the slide, Jason. All right, overlifting attacks. So these are also very lock dependent. Not a very universal approach as you would have with, say, single pin picking, the clearly superior approach. However, taking all into consideration is always good. So, overlifting. Remember how I showed that diagram earlier with all the pin stacks and stuff, and how you have to move the key pin up to the correct level on the core in order for them all to shear? What if you didn't want to do all that? You could just, on some locks, shove both the key pin and the driver pin up into the body of the lock and then turn the core. You need a very specific set of tools for this. It's called a comb, I believe. And some locks are vulnerable, some are not. The fix is to just not have all this space like right here. We actually ordered some of these for the RTSEC Physical Security Interest Group, but I don't think they're here yet.
They're here.
Or something. They are?
Yes, sir.
Oh, dude, it's over, bro. All right, Jason, next slide. Poor favor. Impressioning. This is like a whole talk. Impressioning is, especially for pin tumblers, is very interesting. I've done it like once and I was unsuccessful, so that's my experience. But the idea, I do understand the idea. I do understand the concept. What are you doing, boss? There's like 2 more slides. The idea is you take a key blank and you stick it in this big handle that allows you to get a lot of kind of leverage on it, and you turn it in the lock so that you've bound up one of the keys, like as we or one of the pins as we were talking about with tensioning before. And then what you do is you rock the key up and down so that the key blank is pushing up on that bound up key pin. And what that'll do is the resistance there and the contact that it's making, it will leave an impression on the key, hence the name, I guess. But what'll happen is that'll tell you that key is too high and it's binding, right? And it's very hard to see. You need like a magnifying glass. And then once you find it, right, then you take a file and you'll knock that spot down 1 key bitting amount. Like, you know how I was talking about how there's 7 different heights for a key pin? You've just determined that one is not the smallest, so you move up to the next one. And that's what you're doing there. Just kind of filing down. And then once you do that for all of the pins, because once you'll know that you've done it successfully for 1 pin once the impression stops showing up on the key. And so then you move on to wherever the next one shows up, and then you go through for all 5 or 6 pins, however many there are, and once done, if you've done it correctly, theoretically you will have a working key, which is nice because you don't have to be any sort of master wizard locksmith to use it. Anyone could use it. And then you have these, which I know I've mentioned before, but these are tubular lock self-impressioning tools. They work on a similar principle, sort of. They have all of these little kind of feelers that go around the center, what is that, shaft there, I guess. And they make contact with all the key pins on the tubular lock. And this works on ones where the drivers are all the same length and the springs are all the same strength. So the only variable in there is the length of the key pin. And what that will allow you to do is these kind of get pushed back disproportionately based on how long the key pin is. And what you'll get is if you press this into there enough times, it will push these back in such a way that you have impressioned a key. And some nicer ones will allow you to kind of wrench down on it so that none of these rods move again. We have the Chinese ones, so that's not really an option for us. But I mean, the idea is still the same. So you can impression a key that will work like a lot. If you would, Jason. Okay, so I mentioned this a bit before, but decoding attacks for combination locks. If you stick a thin piece of metal between the dials, you can sometimes find the gates within the wheels that actually make contact with the little mechanism up here that will be opening the lock. This is a Master Lock 175, and we actually ordered one of these because there's a lot of attacks that you can demonstrate on these. And chances are you've seen one of these before, right? Like, these are everywhere. There's an attack, a bypass attack, where you just kind of stick one of these through one of the dials. And if you can see this kind of comb thing in there, if you make contact with that, push down the shackle, push up on that, boom, it's open. You didn't have to do anything with the code. But you can also just kind of stick it through next to the dials, and there's some stuff you have to feel for, but you'll be able to tell which one is the one that it's currently set to unlock. And I think that was my last slide. Oh no, this is my last slide. So everything outlined thus far has been a non-destructive attack. Say you were of more the criminal persuasion, you would be able to kind of use some. I mean, if you think about it, like, no criminal is gonna do all the stuff that I just outlined. Like, that takes work, bro. Just go to friggin' Harbor Freight, $20 bolt cutters, and you can like destroy like every lock. Or if you're even more high tech, if you're going for the real high security locks, you can get a cordless angle grinder and some metal cutoff wheels. That thing will cut through like any lock in like a couple seconds. And I mean, if you think about it, like the way security on residential works is you have locks, but they don't necessarily need to be like the best locks. Because I mean, like, if someone wants to get into your house, like, they could probably just take a brick from your garden and throw it through your window. Like, it's just kind of how that works. So, destructive entry. We have a week on this just because it's fun, but that is my truly last slide. I mean, if you see this cutter here, it says Bauer on it. Like, that's definitely not a coincidence. John Bauer is a goon. He's a criminal. He comes to the ROTC Physical Security Interest Group every week, so like, can't really knock him for anything, but that's my time, or even more, I think. Can I get my flash drive?
Yeah, I'll give it to you after. If only there was an interest group that did this too. That'd be nice.
Tell us more about the interest.
Huh?
Tell us more about the interest.
Oh, it's just Mondays from 11 to 12 in Golisano, 1730.
What time is it?
Over there
Today?
at 11 on Mondays. You know.
I don't
No
know, you gotta
biggie.
tell us a little more.
Thank you, buddy.
Is that Captain Ken?
Very well might be.
What's up, Ken?
Here with Wyatt.
Dude, got some of my presentation, bro.
Yeah, it's pretty.
Are we slamming right in the research today?
Yeah, we're
Sorry, bro. That whole enrollment thing and whatever just happened, it just screwed everything up. No demo. I was thinking about making